Guys, in this video, I'm gonna cover the last problem of the biweekly contest 130. During the contest, I was able to solve three of them. The last problem I wasn't able to solve. So, in this video, I'll cover the last problem. So, what does it say is find products of the element of a big array. Let me just read out the problem statement and quickly explain you what is it talking about. Later, I will get it into the solution. A powerful array for an integer x is the shortest sorted array of powers of 2 that sum to x. For example, the powerful array of 11 is 1, 2, 8. Actually, what is it saying is, let's say you have any number x, either odd, even, anything, it can be anything, and powerful array for that integer x is the shortest sorted array of powers of 2. So basically you need, let's say 11 is given, and you need to write 11 in the powers of 2, and the array should be short and it should be sorted also. So 1, 2, 8, 1 is 2 power 0, 2 power 1, and this one is 2 power 3. 8 plus 2 plus 1 comes out to be 11. That's what this is, powers of 2 that sum up to x, and it need to be shortest also. How it can be shortest, I'll tell you in a bit. The array next the array big nums is created by concatenating the powerful arrays for every positive integer I in the ascending order 1, 2, 3, and so forth. Thus the big num starts as like this. So what does it say is, you would have understood what is a powerful array. Now the array big num is a collection of powerful arrays, and the powerful arrays of x, where x goes from 1 to 3 and so on. Powerful array of 1 is 1, powerful array of 2 is also 2. Why? Because for 1 we can represent it as 2 power 0, for 2 we can represent it as 2 power 1, and for 3 it can 1, 2. So these two combined is a powerful array for 3. Next 4 will be as 4 only. Why? Because it is already a power of 2. And next 5 is 1 comma 4, and 6 is 2 comma 4, 7 is 1 comma 2 comma 4, and 8 is 8, and 9 will be 1 comma 8, and 10 will be what, 1 comma 2 comma 8, and 11 will be 1 comma 2 comma 8, and so on so forth. Next, these 2 points now you would have understood. The third point says that you are given an 2D integer matrix queries, where queries of I is from, basically queries of I is in the format of 3 element, from I to I mod I, and I need to calculate big nums from of I into big nums from I plus 1, so until big nums of 2i and whole mod I need to do. Basically, I'll let you know how through an example. Query is given. There is only one query here, 1 comma 3 comma 7. What I need to do, I need to get the big num of 1, big num of 1, big num of 1 plus 1, 2, so until big num of 3. That's what written here, 1, 2, so on till 3. I need to multiply each and every big num element, and finally take the mod of that product with 7. So basically, bignum of I means not the powerful array of I, it is the bignum of I. So see, bignum of 0 is 1, bignum of 2 is 2, bignum of 3 is 1, bignum of 4 is 2, bignum of 5 is 4, 6 is 1, 7 is 4, 8 is 2, like that. It is zero based indexing, don't get confused. Bignum of from of I means bignum of 1, and which is 2 here, it's zero based indexing, right? Bignum of 1 is 2, and so on till third element, 2, 1, 2. Multiply 2 into 1 into 2, which is 4, and take the mod with 7. Again it will be 4. Why? Because 4 is less than 7. Similarly, we need to do for queries can be any number, like it can go up to 500. Queries of I dot length is obviously 3 from I to I mod I, right? And there can be 500 queries at a time and to manage that. So this is basically the problem. And let me just for if there are multiple queries, you need to get a vector of the answers connecting to the respective query. For 253, bignum from second element, first, second, sorry, this is 2, right? 0 base indexing, 0, 1, 2. This is 2, 3, 4, 5. It is still here, 1, 2, 4, 1. 1, 2, 4, 1, yes. 1, 2, 4, 1. Multiply all of these, 1 into 2 into 4 into 1, which is 8. 8 modulo 3. How much it will be? 3 twos are 6 and 2. Remainder will be 2. And 774. It is only one element, which is the seventh element, which means seventh element in the sense 0, 1, 2, 3, 4, 5, 6, 7, 2. That's it. 2 modulo 4, it will be 2. Why? Because 2 is less than 4. Now you would have understood the question. Let me get into the answer how you can solve this. So basically, if you read the first point, bignum's array is a power of 2, so we can represent it with the power only. So what does it mean is, let me just create a duplicate slide. I don't have a pen to write. Sorry, not a duplicate one, new slide. Hmm. Since this is the bignum array, if you read the first question, it says that bignum array is all the power of 2, so we can represent it with the powers only. This is basically a power of 2, like it is written in the 2 power some x, and where x is for 0, this is 1, this is again 0, this is 1, this is 2, this is 0, this is 2, this is 1, this is 2, 0, 1, 2, 3, so on. Basically what I did is, this is the x value, this is basically in the form of 2 powers of 2, 2 power x, where x is, for this element x is 0, 2 power 0 is 1, 2 power 1 is 2, 2 power 0 is again 1, 2 power 1 is 2, 2 power 2 is 4, 0 is 1, 2 power 2 is 4, and it goes on like that, 2 power 3 is 8, and so on. This is basically the array x. And why I did like this is, if you read the second point, once converted, the multiplication becomes addition. Basically, we need to multiply the elements from here to here, right? So instead of multiplying them, 2 power, let's say we need to multiply it from the third position to the fourth position. Let's say multiply it from second position to the fourth position. So basically, what you will do, 2 2 into 1 into 2, right? So instead of doing that, you can just add the powers. It will give you the same answer. 1 plus 0 plus 1. So multiplication will lead to the integer overflow error, whereas the addition can control that error. So once converted, multiplication becomes addition. We will need to sum the values from query of 0 to query of 1. Basically, instead of writing the query of 0, we can write it as query of I of 0. This will be make better sense. And query of I of 1. This is the from I to 2i. By, instead of multiplying, we can convert it to addition. And instead of doing the addition also, we can easily convert this addition to what if they obviously will be getting the from I to 2I, not from the beginning to end, it will be some other elements from the middle, right? To calculate the sum from here to here, what we can do is use the concept of prefix sum. Get this, let's say we need to get the sum from here to here, we can get the prefix sum of from here to here, and get the prefix sum from here to here, and just subtract it, this sum minus this sum will get you this sum, will get you this sum. So that's the concept of prefix sum. If you aren't facing some problem with the concept of prefix sum, this is a standard problem, you can search through Leetcode and you can solve that. So prefix sum till 2 of I to I minus prefix sum from minus 1 I, that will get you the answer. To calculate the prefix sum, what you can do is again create an one another function called prefix sum till index, and inside that you can write the sum of bits from 1 to value using the another function called get value from index. That get value from index can be solved using the binary search. Why? Because instead of doing the sum from 1 to n in o of 1 in in o of n complexity, if you use the binary search, it will get reduced to the complexity of o of log n. There is no problem of using the o of n, problem can be solved using o of n as well. But in order to optimize more the problem, just create one another function called sum n count bits before value, and use that function to calculate the get value from index prefix sum using the binary search. When you know the concept of binary search, you need to get low variable and high variable, calculate the mid by low plus high divided by 2. In order to prevent the integer overflow, you can write high as high minus low by 2. This by simplifying will get you low plus high divided by 2. And basically you can also use the concept of number theory to write a simple way of multiplying x power y, and with along with the mod. Just use the bit manipulation to multiply the x power y instead of using the pow function. If you use the see the complexity of pow function, it's more than mo of n, but this can be solved with a much lesser uh, time complexity, pow of x comma y. Instead of using this, you can write this actual power of x comma y using bit manipulation. So once you combine all the sub concept and write it in a code, you can solve this problem. Thanks for watching this video.